Okay, so simulating results. So here we want to simulate a 25% chance of success. So with a die have 6 sides, but 25% in fraction form would be 1/4. Okay, so one way we could do this is if you roll a 1, we consider that to be yes, you're going to vote. If you roll 2, 3, or 4, that represents no, not voting. And then if it's a 5 or 6, you re-roll it until you get something that's not a 5 or a 6. Right, so then 5 or 6 aren't really outcomes because you just redo them. So 1 out of the 4 outcomes, or 25%, represent voting. Okay, how about with a coin? Well, a coin has only 2 outcomes, and we need to get to 4. So if we consider like a tree diagram, okay, so after 2 coin flips, there's 4 different outcomes, right? It could be heads and heads, heads then tails, tails then heads, or tails then tails. So we could say that if you get heads and heads, that represents voting, and then anything else is not voting. Okay, so again, you're flipping 2 coins. Or flip 1 coin twice. Okay, how about with a deck of cards? Okay, well, 1/4 would be, we could do, there's 4 suits in a deck of cards, all with equal numbers of cards. Okay, so just pick one of them. So we could say draw a card. If you get, doesn't matter which suit, so say if you get spades, you consider that to be a vote. Any other suit you could consider to be not voting. Okay, and of course you would have to shuffle the card back in every time to keep each individual probability independent. Okay, an expected number of surveyed adults who will vote. So if the individual chance of someone voting is 0.25, and then you're gonna survey 80 people, then you do 0.25 times 80, which would be 20 people. Okay, so each monster you defeat has a 40% chance of dropping an item. So after you defeat 70 monsters, how many items will you get? Okay, so how are we going to simulate this? So 40%, that could be 2 out of 5 or 4 out of 10. Okay, so one way you could do it, so we could use a 6-sided die. Okay, so we need 2 successes. So let's say if you roll a 1 or 2, we're going to say that means an item dropped. Okay, so then we need 3 failure options. And then if the 6th side comes up, you just would redo it. So then there's only 5 real possibilities, and 2 out of 5 are successes. Okay, so what about a deck of cards? Okay, so maybe it's better to do the 4 out of 10 here. Okay, so we could say if you, well, so you're going to draw a card, right? Okay, so if the value is a 1, 2, 3, or 4, you consider that an item. If it's a 5, 6, 7, 8, 9, or 10, you consider that no item. And any other value, so a face card, oh, a 1 is really an ace, sorry. Right, so any other value, you just redo it. Okay, so expected value, we have 40% chance each times 70 is 28 expected. Okay, so HQ trivia. So if you randomly guess on all 12 questions, well, each question has 3 choices. So let's get down to the nitty-gritty. You've got 1/3 probability of success on a single question times 12 questions total means you expect to get 4 right. Okay, so how can we simulate the results? How can we simulate a 1/3? So if you roll a die, we could say 1 or 2 is correct, and then anything else is wrong, right? Because that means 2 out of 6, which reduces to 1/3. Okay, we could also do this, I guess, with a deck of cards. So there's 13 values, so we could make the 1/3 equal to 4 out of 12. Okay, so 1, 2, okay, and there's no 1. Ace, 2, 3, and 4 will be considered successes. The next 8 values are considered failures, and if you get the last value, you just have to redo it. So then, ignoring the kings, because we're just going to redraw, out of the 12 other values for our successes, 4 out of 12 reduces to 1/3.